In this lecture, we're going to be talking about output and interpreting model results. So in this lecture, we're going to go over what the output looks like in M+. I'm also going to talk about the different kinds of output commands that you can give and how to interpret the output. So first of all, I thought it would be important to talk a little bit about the three different file types that that M+ saves. So these are, when I talk about the file types, I mean like .doc is Microsoft Word and .ppt is PowerPoint. So in M+, there are three different files, types of files that it will save. You have your .in, which is your input file. That's the file that you do your syntax writing in, and .out is the output file. That is the file that has your model results, and then .dgm is your diagram file. That's if you request that one, it gives you the diagram of your model. So, but before I get into the order of the output and what's in there, I want to talk about really the order and what you should look at in your output. The first thing you should look at in your output is pay attention to warnings or errors. If you remember from the past lectures in this series, in this class, I've noted that sometimes M+ will still give you results even though it has significant warnings or errors that it is concerned about. So first, check your warnings box. After you do that, then run down and check your model fit. There's not much point to checking any results if your model fit is terrible. If your model fit is poor, you can run in your output to get model fit indices that can tell you what you may want to adjust in that if you've included that in your output. So first, check model fit after you do the warnings and errors. And then third, check your paths. And what I mean by this is make sure that the syntax and the paths that you meant to ran are actually the ones that you ran. So double check your syntax, double check your paths that they're correct. And then if you've got no warnings or warnings you don't need to worry about, if your model fit is adequate and you've double checked your syntax and double checked your paths and it looks good, then after that, now we look at our results. So it's important to make sure that you don't jump the gun and go straight to results. Make sure you check your warnings, make sure you check your model fit, and make sure you double check your paths before you get to looking at your results. So a few things about output in M+. The output in M+ is highly customizable. So what I mean by that is you have a lot of subcommands. So you can really get a lot of different kinds of things in your output. So what you get in your output is really largely based on what you request M+ to give you. I'm going to go over the most common and basic ones in this lecture today. There are certainly many, many more. And you can look at the M+ handbook to get a description of all the different kinds of output that you can request. And a few tips about output in M+. One, there's no formatting. So you can't just copy and paste a table because there's no rows and columns. It's not built in table form. It's basically built in a text document form. The good news about that is that you can write in notes right in your output files, and it's quite easy to do because it's just a text document. I suggest you kind of go to the far right of whatever column you write a note in, and then you just write in your note right there. It's an output file, so you don't need to worry about anything around it. Screw anything up as long as you're not making things move around on lines and things like that, but you can put notes right in there, and I've done that many times where I would put in a description of what this means, or especially around like moderation analyses, putting in the interpretation of the results right there, right in the output file. What you do have to be careful for, though, is if you go back to your input file, make any changes and hit run again, unless you've changed the file name, it's going to save right over that old file. So like I've talked about in the past, it's really good to have good practices in saving documents that you use the date or something in the file name so you don't accidentally overwrite an old file that you may want to keep. So in your output, one thing that you're going to really want to know is where is the standardized and where's the unstandardized output, and where do I read that? And what I mean by that is, your unstandardized beta coefficients, factor loadings, those kind of things, and then your standardized correlations and beta coefficients. And the M+ output, just underneath the model fit indices, it'll say model results. That'll be the header there. Those model results header, that's the unstandardized output. So when you are looking for the unstandardized output, there are certainly times like when you're doing multiple group comparison or moderation analyses, you want to use the model results. So use that right there. If you're looking for the standardized output, there are three different types of standardized output that MPlus will give. And it calls this STD, STDY, and STDYX. So the STD you can pretty much ignore. There's really never any time that you would be reporting the STD standardized results. STDY standard results are for binary covariance. So for dichotomous variables, you will want to include in the STD, you'll want to look at the STDY output. If you have continuous variables, which for the most part you should really just have continuous variables with very few exceptions, you're going to look at the STDYX output for the standardized. So the vast majority of the time when you're reporting standardized results, you're going to do that STDYX. So some of the subcommands you can do in your output. So this is where you hit output colon and then you write these in and semicolon at the end. So some of the common ones are STDYX. So that's literally to get only the STDYX output. And if you have all continuous variables, that's all you need. You just do that one. If, however, you have some binary or dichotomous variables in there as well, and you need the STDY standardized output, you can just type in standardized. That will give you the three sets of standardized, STD, STDY, and STDYX. For the most part, at 90% of the time, you're just going to use the STDYX just to get that standardized version. SAMPSTAT is another common one that stands for sample statistics. This gives you a whole slew of statistics around means, variances, covariances, correlations, skewness, kurtosis, tons and tons of stuff. However, you're really never going to use SAMPSTAT or need it because you'll get most of this information in your preliminary analyses and SPSS. So you'll run your skewness, kurtosis, normality, all that kind of stuff. You can do that when you're doing your preliminary stuff right there in SPSS. So you're really never going to need this in M+. Mod indices is modification indices. So this one helps you to figure out if you add this path, how much it'll change your chi-squared value in your model fit indice. If you do mod indices and then put 3.84 in parentheses, what you're doing is you're telling M+, give me modification indices that increase chi-squared by 3.84. Now 3.84 is the point at which chi-squared is significant at 1 degree of freedom. So that's why I do 3.84, so that way if you do mod indices 3.84, it will give you individual paths that you could add in or remove and increase your chi-square significantly in your model fit. So if you do this, mod indices 3.84, if you include this in your output and you have poor model fit, you can see what you may need to add or could add that could give you better model fit. Now keep in mind, you just don't want to add anything because it will give you anything and everything, including things that will give you non-recursive models and things that just don't make any sense whatsoever. So do make sure that you carefully consider those modification indices before you decide to just add one just to make the model fit and force the model fit to fit well. Patterns is another common one that you may want to use. This one gives you patterns of missingness, where it'll actually give you information about what kind of variables are related to missingness, and you can actually account for that in your model if necessary. Cinterval gives you confidence intervals, and particularly Cinterval and then bootstrap in parentheses is one that is commonly used when we're doing mediation analyses, so you can do bootstrapping in your mediation analysis. And we're going to talk about that later when we get to mediation moderation in this semester. So the order that things will appear in the output of SPSS are as follows here on this slide. So first, it's going to have your syntax. So when you hit run and you see your output window pop up, you will see it'll have the exact same thing that was there when you're doing your syntax. It'll just be in all black and white. There won't be any colors around commands and subcommands and that kind of stuff. After the syntax, it'll then have any warnings or information that might be important for you to have. So warnings, errors, and then it'll also have information about how many observations there were, how many variables there are or parameters that there are in the analysis. And then after that, if you've done that SAMPSTAT, you'll have all your sample statistics. So it'll give you that first. right after the warnings information, and that'll be quite lengthy because it gives you a ton of information. If you have not run that, or if you have, the next thing that you'll see is the model fit indices. So it'll give you first your copy of syntax, then your warnings, and then your model fit indices. And then after your model fit indices, it'll do model results. Remember, that's your unstandardized output, will be right there. And then after that, it'll depend on what you've asked M+ to give in your output. If you've done standardized or STDYX, that'll be right below your model results. And then if you've done confidence intervals, that'll be after that, and or whatever else you've asked for, mod indices, modification indices, whatever you've done will be after those model results and after your standardized results. So in your output, this is the important part of the output. After you've double checked, that you don't have any warnings, that your model fit is good, and that your paths are accurate in how that you wrote them. Here is actually your output. So you can see here, this is the STDYX standardization. So that is our standardized output for continuous variables. And then it will have 4 columns: estimate, SE, estimate over SE, and two-tailed p-value. Your estimate is your path analysis, or your path value. So that's the value. If this is a regression loading, it's your regression beta weight. If this is a factor loading, then it'll be a factor loading score. SE is your standard error, so that's the error associated with the regression coefficient. EST over SE is your t-value. If you remember, the t-value is calculated from dividing the estimate over the standard error. So this is very similar to what you would see in SPSS, where you have your estimate, your standard error, your t-value, and at the end you have your p-value, so your two-tailed p-value. And that's your output. So I'm going to give you an example here on one of these to show you how you would interpret this. So here is an example of output and how you interpret it and write it up. So I have circled here one of the path coefficients. So the first part on this, above the circle, you'll see there's f-by and m-by. Those two are latent constructs. I'm not going to interpret that one here because we're going to get to that one in our next module on confirmatory factor analysis. So I'm going to go down to the regression output. So you'll see m on f-game acceptance. So m is men's dyadic adjustment, and f-game acceptance is females, so women's acceptance for gaming. This is from a paper that I've actually published, so this is actually real data and real output. So the way you read this then would be f-game acceptance is, that has an arrow to m-. So in this, the way you would interpret it is the exact same way we talked about in multivariate statistics about interpreting regression coefficients. So there's absolutely nothing new here about interpreting. So the estimate there you can see is 0.068, and the p-value associated with that is p is .000, which really means it's less than 0.001. So rounding to 2 decimals then, you would then interpret this as women's acceptance for gaming, that's f-game acceptance, so women's acceptance for gaming is significantly associated with men's dyadic adjustment, with beta equaling 0.07 and p less than 0.001. Or alternatively, you can write it as women's acceptance for gaming increases by 1 standard deviation, men's dyadic adjustment increases by 0.07 standard deviations. So we're just following that same formula we talked about in multivariate statistics. As IV goes up by 1, DV changes by beta. Or you can also say that IV is significantly associated with DV. So those are 2 ways that you can write this up, and you do it the same way for every other variable. You can see going down. So M-game acceptance, you can see that one's not significant. You can't see that F-game frequency is significant if we go a few rows down. So we do the same thing where we'd say, so women's gaming frequency is significantly associated with men's dyadic adjustment, with beta equaling 0.02 and P being less than 0.05. So this is how you would interpret those results. We're going to go into more detail a lot with these other results as we move through the semester and look at other examples like mediation analyses, how we interpret indirect effects, or moderation analyses, how we interpret the interaction terms, especially next week when we cover confirmatory factor analysis. We'll talk about how to actually interpret the factor loadings that you'd see at the top end of this output. So that's M plus output in a nutshell. Don't overthink it because it's not too terribly complicated, and it should be pretty familiar based on everything you've done in multivariate statistics. After this video, you should see another video up here where I am covering or actually going through some examples in M plus, and then next week we're going to cover confirmatory factor analysis.